Hello, my name is Parth Pandya and I am Associate Product Manager of our 1D Fluids product at Realis. And today I'd like to talk to you about what's new in our 2023.2 release in our 1D Fluids product Wave and Wave RT. Welcome to 2023.2 release of Wave and Wave RT, your high fidelity digital twin for ICE engine plant development. With Wave Product Suite, our customers can accelerate virtual product development and take advantage of the latest R&D. Realis products put customer at the center of the decision making and deliver a personalized experience while minimizing development cost for our customers. These five pillars of our product strategy firmly put the customer at the center of our product development. Today, it is my pleasure to introduce new and exciting features in 2023.2 release of Wave Product Suite and give you an overview of how these features can help our customers achieve their R&D and CAE modeling objectives. The 2023.2 release is packed both with features which are addressing new simulation challenges and features which enhances usability and help our customers speed up their workflow. With this release, we are continuing the theme of accuracy, usability, and speed which underlines Realis simulation fluid products. The new physics modeling functionality headlines include enhanced thermal modeling in real time, new flame speed model developed for lean hydrogen applications, and new options for multi-fuel modeling for knock and laminar flame speed. The modeling enhancement of interest to motorcycle customers also include new dynamic valve lift profile and ability to model easily complex mufflers with internal tubes. The user experience is enhanced through new plotting options for acoustic and autosave features for our 3D modeling preprocessors, as well as new tabular editor and case table import-export. On the workflow enabler front, we continue improving our products to speed up the creation and conversion of complex models, introducing the new parameters to actuators conversion tool. The users of Realis queuing service, a simple yet powerful cluster management tool, will benefit from new options enabling faster operations on slow networks. Finally, this release features numerous improvements in GT importer tool with the specific focus on rotary engine application, helping our customers convert their legacy models easier and enjoy the benefit of wave modeling environment. Let us dive a bit deeper into selection of these features highlighted in bold. We will also cover briefly other enhancement in this release at the end. If you have any questions about the features we cover or would like to know more about how Realis product can help you enhance our CAE workflow, please reach out to us at support@realissimulation.com. Let us start with the physics enhancement. We are continuing to improve the fidelity of our real-time solution WaveRT. As the fidelity of the real-time digital twin improves, its application can be expanded outside of the classical realm of virtual calibration and vehicle system level simulations. With the enhanced fidelity, our customers can take advantage of using accurate predictive faster than real-time solver for other applications such as the development and calibration of the cooling system. To enable this application, we need to be able to capture the heat flows through the engine block accurately while keeping real-time performance of the model. The solution comes in the form of enabling axial conduction in WaveRT with minimal penalty on the run speed. This new feature ensures accurate thermal response can be obtained, not only for the cylinder head but also for ports, notably for the intake port part of the engine block. Axial conduction can be enabled on demand and is fully configurable, offering users option to switch it on for the whole plant model or for a desired subset, for example engine block only. This new feature is illustrated in the engine thermal balance examples for natural and turbocharged engine available in Wave installation. The next key feature of 2023.2 release is lean hydrogen turbulent flame speed model. Accurate combustion modeling is one of the main development direction of the Wave product suite. This release introduced a new flame speed model which has been implemented specifically to address the challenges of lean hydrogen combustion and deliver predictive capability for lean hydrogen operation. Under lean conditions, hydrogen exhibits thermodiffusivity instability, which strongly affects propagation of the flame at pressures and temperatures typical for ignition condition in ICE engines. In 2023.2, we combine the new Ximon type turbulent flame speed closure with the power of surrogate optimization in Realis RDesk Tuner to accurately model lean hydrogen and rapidly determine the optimal value of the tunable parameters of the combustion and turbulence models to deliver accurate predictive engine model for conventional and real-time applications. The model has been demonstrated to perform well for lean operations and be able to capture the speed, load, lambda sweep with a single set of model parameters. Examples of hydrogen single cylinder research engines are provided for both desktop and real-time functionality. Note that the model also shows good accuracy for conventional fuel, especially when combined with kinetic tabulated laminar flame speed available in Wave and Wave RT. In the plots, the points representing three sweeps, speed, load and lambda have been calibrated using RDesk Tuner to determine optimal model parameters for this engine. Firstly, heat transfer parameters, Washington heat transfer coefficient, intake and exhaust port heat transfer multipliers and cylinder heat transfer multipliers were calibrated for VBA prescribed model. With the same heat transfer setting, SR predictive combustion model was calibrated with and without using thermodiffusivity laminar flame speed for fractal turbulent flame speed model present in previous release and Ximont turbulent flame speed model introduced in the current release. The new model is available for both Wave and Wave RT, but calibration was run in RT to speed up the process. Calibration parameters are as follow: fractal model, burn area decay exponent, ignition radius, engine speed exponent, plus parameters of the turbulent model. Plot labels are fractal and fractal plus TDSL. Ximont model, burn area decay exponent, K, A, B, and parameters of the turbulent model. Plot shows that the best calibration and the fractal model cannot capture the sweep using laminar flame sweep with thermodiffusivity improves things but not a lot. Ximont captures the sweep much better. Ximont model with thermodiffusivity flame speed offers best accuracy. Synthetic fuel such as synthetic gasoline can offer a viable solution for the decarbonization of internal combustion engine applications. The ongoing pilot production efforts undertaken by both oil companies and automotive OEMs are showing promise. One of the challenges in the application of complex synthetic fuel is a variability of the fuel composition. This issue also affects some market with existing fuels where, for example, the composition of biofuel content can vary depending on the region. To build accurate models for these applications and market, it is beneficial to consider fuel variability during the model construction stage. For example, utilizing a multi-fuel approach to represent individual fuel components. To help our customers address this challenge, in this release, we have extended NOC modeling in Wave and Wave RT to support multi-fuel applications. We have also extended multi-fuel laminar flame speed modeling to support Gilder correlation approach. The multi-fuel NOC modeling is available for Dowd and IZART correlation as well as ignition delay interpolation maps based on detailed chemical kinetics. The existing NOC model has input for each fuel. Dowd and IZART and the mapped induction time models calculate the induction time for the mixture of fuel is calculated from the induction time of each fuel. The extended Gilder correlation for multi-fuel simulation is available as an option for laminar flame speed model. Gilder correlation has a great performance near stoichiometric condition and as such is a good choice for modern gasoline engines. In the plot we see the comparison of NOC intensity for an engine running on blends of ethanol and isooctane when simulated as a dual fuel with separate injection of ethanol and isooctane, which is shown in green curve, and when simulated as a single fuel with fuels and NOC kinetic fit tables prepared for each ratio of the blend separately. The results show that the two approaches are in good agreement and it is possible to create a model with dual fuel injection and use it without changing the model to represent a variation of ethanol content in the supplied fuel. The next feature that aims to improve the user experience is internal tube modeling enhancement. Accurate acoustic modeling, especially when dealing with the intricate geometries of component, present a significant challenge, particularly in the motorcycle industry, where the muffler structure can be quite complex. Wavebuild 3D, with its support for complex CAD geometries, is enabling our customers to address this challenge. In our drive to constantly improve the usability of the acoustic preprocessing workflow, We have expanded the ability to model internal tubes in this tool, simplifying the overall workflow and saving engineers time. This enhancement allows Webull 3D to effectively model a wider array of acoustic mufflers, encompassing configuration like a straight tube situated inside another. The functionality accommodates various setups for both tubes, such as internal pipe being offset and or inclined to an external pipe. It also covers scenarios where both tubes are perforated and the internal tube spans multiple sections of the external tube. It is important to note that for the tube to function as an internal tube, it must fully insert into another tube. Upon meshing, the inserted tube seamlessly integrates as an internal component of other tube. The next feature, Tabular Editor, aims to improve the productivity of our users. 1D engine models constructed for modern engines can feature remarkable complexity, and mistakes in model construction can be difficult to spot, causing substantial delay in model validation, or in the worst case scenario, incorrect results propagating into design conclusion. At Realis, we are constantly adding new features aiming at simplifying model analysis and troubleshooting. 2023.2 release features a new tabular editor mode which can be used to present properties for the set of element in a user-friendly table, allowing a quick at-a-glance check of element properties. The tabular editor can be applied both to sets of elements of the same type and elements of different types. It also supports copy paste from spreadsheet format and customers to define quickly the properties of model elements based on in-house Excel templates. The new feature is available through the context menu when a set of elements is selected. It can also be applied to a single element, providing a convenient tabular view of elements property. The video shows the selection of the exhaust port and editing them in the tabular editor. By examining the table, we identify the and correct the heat transfer coefficient which was not set to a parameter in one of the port, illustrating model troubleshooting with this new functionality. Continuing with user productivity enhancement, the next feature is import and export of spreadsheet. One of the useful feature of a CAE software package which helps customer minimize the development cost is its interoperability with the broader CAE software environment. Spreadsheets such as Microsoft Excel are ubiquitous as a means of data sharing in engineering workflows. In this release, Wave parametric case tables offer a new feature allowing import and export of the whole or part of the case table into Microsoft Excel or open comma separated value formats. The functionality can be useful when importing standardized test data spreadsheets into Wave, as well as a method for automating the definition of operating point. The feature can be accessed through the toolbar of the case table view. The video shows export of the case table into CSV file. We can then open the CSV file in Excel and change the data. For example, exhaust port temperature. The data can then be re-imported into the session. Note that the parameters are matched by names and new parameters are created automatically if they are not present in the session. Also, cases are matched by name for cases which are present in both imported spreadsheet and the session parameter values are updated. Cases which are not present in the session are added during import. The next feature aims as workflow enabler with rapid model instrumentation. Conversion of a steady state model to transient operations and preparation of the model for export into broader simulation environment is a standard task for CAE process for performance and acoustic simulation. Speeding up model instrumentation can improve productivity and save engineers time. 2023.2 release of Wave features a new tool allowing a rapid conversion of model parameters into actuators connected to elements using a simple wizard dialog with advanced filtering capability. This simple enhancement can both save time in model construction and help avoid costly mistakes as it provides a convenient tabular view of model listing all applications of parameters to be converted. The new tool is accessed through Wave RDisk GUI toolbar. The next key headline is robust distributed simulation. Distributed calculations are a must for modern CAE engineering workflows. They are a powerful accelerator of the development process, but setting up an optimal simulation distribution system can be a complex task. Speed of access to shared storage can be a particular concern when configuring Windows clusters. Realis queuing system provides a simple yet powerful method for configuring computational resources, be it a single physical Windows server shared with a small engineering team or 1000 plus CPU Linux computational VM setup. In this release, we have added new capabilities to run distribution which are aimed specifically at simplifying submission of distributed jobs in Windows or heterogeneous environment on and off VPN. This include ability to run job results merging directly on the cluster as opposed to be submitting node, which both speeds up merging of simulation results and make it more robust on slow networks. Potential slowness of Windows network share is also addressed through the new option allowing automatic copying of files required by the simulation to the local storage of the cluster. Finally, a new option to send a run distribution job to Realis queuing server without running job distribution controller on the submitting node would be of interest to Realis customers working on VPN. In essence, it enables running on corporate networks with tight security requirements where the cluster cannot communicate to the customer's laptop when on virtual private network. The options are available through distributed panel of RDisk and GUI. Apart from the key headlines features, this release is packed with other enhancements for Wave and WaveRT and accompanying tools, such as dynamic valve width profiles available in both Wave and WaveRT, allows easy specification for the valve lift profiles as a function of RPM. New turbulent velocity and flame speed sensors available in both Wave and WaveRT allows easy analysis of predictive combustion model behavior and gaining deeper understanding of engine combustion process. Shrouding now automatically embed auxiliary files with the new control options in the shrouded model export dialog, which simplifies the process of creating self-contained models. A new input check option is available in RDisk environment, allowing running solver on the model in a check mode, providing an option to identify mistakes in the model easily and save time which can otherwise lost, in particular when an incorrect model is submitted to a computational cluster. Finally, RDisk GUI now has comments tab available for all elements, allowing user to store specific nodes to a model element, improving data and setting traceability. Some of the RT specific improvement includes export of parameters and initial values for the PID element allows easy parameterization and actuation of built-in PID controls when running RT model in environments such as MATLAB or RDisk Tuner. It is now possible to actuate mass flow in WaveRT, allowing usage of separate standalone WaveRT models for engine subsystem such as exhaust. A number of new elements are supported in WaveRT such as switch, dual power, torque actuators, etc. Some of the tool enhancements are as follow. RPost has new capabilities for acoustic users, allowing easy plotting of acoustic data versus microphone position and crank angle. New asynchronous mode of operation in RDisk Tuner includes constant as opposed to batch update of surrogate functions, speeding up the tuning execution by up to 25%. Multiple improvements in GT importer aiming at rotary engine operation such as shaft gear connection, imposed piston motion, and multiple scavenging profiles. In Wave, there has been a new set of features aiming to provide user with easier control of the flow through discharge coefficients, including blocking the flow, actuating discharge coefficients in ambient, orifice, Y junction, and inline valve element, and support for discharge coefficient specification without area change. It is also now possible to remesh component inside a Wave FMU, opening options for usage of Wave FMU in optimization tool for acoustic applications. Finally, we continue expanding our material database with this release, including built-in support for complex heavy hydrocarbon representative of hydrogenated vegetable oil for renewable fuel applications and aviation-grade kerosene. Finally, let us have a brief look back at the key features in the past two releases which may of interest to our customers. In 2023.1, the functionalities were detailed fuel compositions in WaveRT, dual fuel support in WaveRT, non-carbon fuel support in WaveRT. The features that aim to improve user experience were new material generation process and new FMU export for Wave. Lastly, the workflow enablers include RS material database for WaveRT. Our team is here to provide more information about these and help you adopt these features and use them to drive your processes. Please get in touch and we will answer your questions and help you explore these functionalities. Thank you for your time. Please feel free to reach out to us if you have any questions or would like to get additional information on any of the features described earlier. You can reach out to us at support@realisimulation.com. Thank you once again.